Assalamu alaikum. In the last lecture, we introduced the concept of graphs and their representation in memory. Today, we'll explore one of the fundamental graph traversal algorithms, the breadth first search or BFS. Let's start with an example. Imagine we want to list all the cities that Serene Air can reach starting from Islamabad International Airport. This problem is a classic case of graph traversal. Starting from one vertex, we want to find all vertices that are reachable through the edges of the graph. Now, the general approach is this. From a given vertex U, we list out all vertices that U can reach in the graph G. We maintain a set of nodes to expand. Each node has a flag that tells us whether it has been visited or not. So step one, we start with ISP, which is Islamabad. We find the neighbors of ISP, and now our set becomes ISB, UAT, SHJ, and Karachi. From here, we find the neighbors of UET, SHJ, and KHI. Now with that, our set now becomes ISB, UET, SHJ, KHI, then Lahore, Peshawar, and Faisalabad are included in this one as well. So after adding Lahore, Peshawar, and Faisalabad, we find their neighbors. Here you can see that we just need to add DXB. So after adding DXB, we are done because there are no new neighbors to add over here. Even though we have some nodes which are isolated, right? We cannot add them anymore because we cannot reach from Islamabad to those particular nodes. So now that we have completed our traversal, all cities reachable from Islamabad are here. So how can we do that in code? Well, here's the pseudocode to do this, which is for general graph traversal. Mark all nodes as unvisited, pick a starting vertex U, and add U to the probing list. While the probing list is not empty, we simply remove a node V from the probing list, mark V as visited, and for each node W of V, if W is unvisited, simply add W to the probing list. So graph has two main traversal approaches, depth first search and breadth first search. Here, depth first search is something that you will read in your own time. We shall cover breadth first search. Or breadth first traversal. So in breadth first traversal, the probing list is implemented as a queue, following the first in, first out principle. Consider this example. A's neighbor are B, C, and D. B's neighbor are A, C, and F. C's neighbor are A, B, and D. D's neighbor are E, C, and F. E has neighbor A, D, F. And F's neighbor are B and D. We start from vertex A. Initially, the visited vertices are empty and probing vertices has A in it. The unvisited vertices are A, B, C, D, E, F because even though A is in the probing vertices, we have not visited it yet. So we visit it, then we remove A from this queue and mark it as visited. Now we find all unvisited neighbors of A, which are B, C, and E. Then we mark them as visited and put them in the queue. Now visited includes A, B, C, E. Next, we remove A. The probing list now includes B, C, E, while the unvisited list includes D and F. After removing A, next we remove B from the queue and mark it as visited. We find B's unvisited neighbors, only F is unvisited. We marked F visited and add it to the queue. Now visited includes A, B, C, E, F, probing includes C, E, F, and unvisited includes D. Next we remove C from the queue, mark it as visited. We find C's unvisited neighbor, which happens to be D. We mark D as visited and add it to the visited queue. Now visited becomes A, B, C, E, F, D. The probing becomes E, F, D. And unvisited is empty now. Next, we remove E from the queue, mark it as visited. E has no unvisited neighbors. Visited becomes A, B, C, E, F, D. Probing becomes F and D. Next, we remove F from the queue and mark it as visited. Again, no new neighbors are found. Now the probing contains D. Then we remove D from the queue, mark it as visited. Now no new neighbors are found. You can see the visited already contains A, B, C, E, F, D, while probing is empty now. At this point, the traversal is complete. So the BFS traversal order for this particular example is A, B, C, E, F, D. Now to compare, once you read about depth first traversal, the order is going to be closer to A, B, C, D, E, F. However, in breadth first traversal, the order is A, B, C, E, F, D. That's all for today's lecture on BFS traversal step and examples. In the next session, we are going to look at Prim's algorithm and Dijkstra's algorithm for finding the shortest path in a particular graph. And the Prim's algorithm is for something known as a minimum spanning tree, which we shall cover later on as well. Thank you.